In this question, it is given that let fx is equal to this, then at x equal 0, you have to find the correct choice. From our choices, it is clear that we have to discuss the continuity and differentiability of both f and f dash. To discuss the continuity of fx, we are required to check the continuity only at x equal to 0. For all other values of x, it is a continuous function, and when sign operates upon a continuous function, the result is also always continuous. This is continuous. Continuous into continuous is continuous. Hence, for all non-zero values of x, this is continuous function. But for x equal 0, the definition of function is changing, and therefore we'll have to check the continuity of fx at x equal 0. At all other values, fx is sure to be continuous. And to check the continuity of fx at x equal 0, we'll be finding left hand limit, right hand limit, and value of function at x equal 0. Clearly, right hand limit, that is f 0 plus is limit x tends 0 plus x square sine 1 by x, and it is clear that as x tends 0 plus, this thing tends to infinity, and when sine operates upon 1 by x, the value of this will go on fluctuating between minus 1 and 1, but the value of this is tending to 0, and tending to 0 into any finite number is 0. Hence the value of right hand limit will be 0. And to find left hand limit, either we can proceed directly as in this case, or we can proceed in this way also, that because right hand limit is 0 and this function is odd, therefore left hand limit will also be 0. Because the function is odd, had the right hand limit be 7, then for x tends 0 plus, if we are getting the answer 7, then left hand limit would be minus 7 because the function is odd. That is, you can remember in this way directly that if the function is odd and right hand limit is non-zero, say 2, then left hand limit will be automatically minus 2 and the limit will never exist. That is, in the case of odd function, limit can exist only if right hand limit is 0. And because if right hand limit is 0, left hand limit will automatically will become 0. Otherwise, you can proceed as in this way also, that left hand limit will be 0. And value of function is also clearly 0. Hence, I can say the function is continuous at x equal 0. He has not specified in the question at which point we have to check the continuity and differentiability, but it is clear that discontinuity or non-differentiability, if it is there, then that is possible only at x equal to 0. And to check the differentiability at x equal 0, it is clear that right hand derivative, that is f dash 0 plus is equal to limit x tends to 0 plus x square sine 1 by x minus 0 upon x, which is limit x tends to 0 plus x sine 1 by x, and the value of this is clearly 0 because this tends to infinity. The value of this portion will lie between minus 1 and 1, and this part is tending to 0. Therefore, the whole thing will be tending to 0. Hence, the answer is 0. Therefore, I can say right hand derivative is 0. Similarly, left hand derivative is equal to f dash 0 minus limit x tends to 0 minus x square sine 1 by x upon x minus 0 is equal to limit that is 0. Therefore, right hand derivative is 0, left hand derivative is 0. Hence, I can say function is differentiable at x equal to 0. Hence, so far we have got the conclusion that fx is both continuous and differentiable at x equal to 0. And now let us discuss about the continuity and differentiability of f dash. Hence, I conclude that f dash x is equal to x square cos 1 by x into the derivative of 1 by x is minus 1 by x square plus 2x sine 1 by x if x is non-zero. And at x equal 0, we have already found that right hand derivative and left hand derivative both are 0. Therefore, I will say 0 if x is 0. That is f dash x is this thing plus this thing if x is non-zero, and f dash x is 0 if x is equal to 0. That is, I can say f dash x is equal to minus cos 1 by x plus 2x sine 1 by x if x is non-zero, and 0 if x is equal to 0. And it is clear that f dash x is not continuous at x equal to 0 because if I want to check the continuity of f dash x at x equal to 0, first I will require the right hand limit, that is limit x tends to 0 plus f dash x minus cos 1 by x plus 2x sine 1 by x. It is clear that the limit of this part is 0 because this is tending to 0 and this is fluctuating between minus 1 and 1. Therefore, this whole part is tending to 0. But when x tends to 0, this tends to infinity, and this fluctuates between minus 1 and 1. That is, the limit of this does not exist. Hence, right hand limit of f dash x at x equal to 0 does not exist. Hence, it is not required to find left hand limit now, because for continuity, left hand limit, right hand limit, value of function, all the three must be equal. Hence, the function f dash x is not continuous at x equal to 0. And because it is not continuous, hence f dash x is not differentiable at x equal to 0. Hence, it is clear that second choice becomes the correct choice.